It's 5 p.m. This is the fifth hour of 24, and it's my great pleasure to introduce Adam Bly. We recently got reconnected via an event that NIH was organizing across different institutes on knowledge graph and knowledge networks. And I was glad to see him here, and I was astounded to see his new research on system. It's not systems like multiple, but it's just one system. We're all interconnected. And I think you will like what you see. And Adam, maybe I can just introduce you briefly, but let me know, do you want me to share the slides or would you like to share them and advance them yourself?
I'm happy to, if I can.
Yeah, I think that will be maybe better. So I will just briefly introduce you for those which don't know you. As I think we all have piles of Seed magazines at home. I still have my own. And I love that magazine. I think that's how we connected originally. And that was a little bit way back in time. But you also were named Young Global Leader by the World Economic Forum. So I enjoyed being there also. So I think it's just really amazing what you have been able to do, and it's even more impressive what you're doing now. So I'm just so glad you're here because what you do is highly relevant also for the multi-scale human reference atlas that we have been working on for 8 years. But it's also relevant because there are many different systems that make up us, including the microbiome, which we couldn't live without. We couldn't digest anything. We really couldn't exist. And of course, there are many, many other ecosystems we depend upon. And in many cases, we don't really understand yet how much we depend on them. So I'm just so glad that you put your energy and intellect into this. And I will just give it over to you. Thank you for being here.
My pleasure. Thanks for having me. It was lovely to reconnect. And this is such an incredible event. I'm humbled to be a part of it. Let me share my screen. All right. So before we begin and dive into the work that my team and I have been working on for the last several years to create system, I think it's sort of useful and important to recognize that while the technology and the design approaches that we'll talk about today are new, are novel, and attempting to put forward a new way of modeling systems and representing systems at large scale. The philosophy that underpins my work and our efforts at System is instead quite ancestral. System is not in and of itself a new idea. It may be the oldest idea. One lineage is indigenous. The Ojibwe have a word, Girinawendimin, which translates to "we are all related." And a great number of scholars, a great number of cultures have intuited through their own faculties, through their own means of accessing the truths of the universe, of the great interconnectedness of our planet, of our species, perhaps of the cosmos. We've just been on this great misadventure toward siloing and secularization of that interconnectedness for various reasons over centuries, whether in the form of nation states, in the form of the creation of disciplines, whether in the way we understand and have in contemporary cultures discretized sexuality or gender. In all manners of life and society and scholarship, we've been on an effort to divide and conquer. And while within the academy, there's been advantage to atomizing and reducing and pursuing reductionism in order to understand the building blocks of life in the universe, cells and atoms, etc., we now recognize the limitations, certainly from a scholarship standpoint, of that reductionism. Within society at large, it's arguably been a means of exercising power and control over what is otherwise a more fluid and chaotic and complex world. The prompt behind system, then the motivation for why I founded the company, and why we're embarking on what will be a generations long project, is this dichotomy, is this incongruity, where on one side, the biggest challenges we face in the world today are systems. They are complex, they are interconnected, they are interdependent, they are nonlinear, they exhibit properties of emergence. We see this in any number of sociological systems. We see this in the effects of loneliness. We see this in the effects of climate change on migration. We see this in the pandemic we all experienced. We see this in geopolitical conflicts and challenges that seem intractable. We see this in the incongruity of a world order that's trying to exercise control over things that are fundamentally borderless, and in so doing, failing. And that's because the knowledge that we need to tackle these challenges, these great complex systems, is siloed. And it's siloed following an architecture that has been with us for arguably centuries, but certainly through technology has been um, uh, deepened and amplified over the last decades. And that's a semantic architecture. It's an architecture that labels like things, and then is designed for an era where the biggest need we had for information was to go find that information, to be able to simply count things, describe things, find the document about something, but not to characterize a system, not to predict outcomes, not to mitigate unintended consequences, not to figure out root causes, not to intervene before things happen. That wasn't our grand vision for knowledge and data, and now it is in the age of AI. And so this tension between rising complexity in the systems that make up life on Earth and siloing of the knowledge we need to advance our understanding and solutions to those systems is the motivation behind why I founded System. And so the question we are motivated by is, what if instead of a semantic architecture for the world's knowledge, what if instead all the world's knowledge was organized as one interconnected system based on learning how everything was related, based on evidence of how the world and all of its constituent pieces was related and is changing in time and space? What if it was just as easy in the future to contextualize a topic or contextualize a decision or contextualize a data point as it is today to find it? And so what we are out to do at System is build really foundational knowledge infrastructure, the substrate upon which we can evolve decision making and hopefully even structures of society, structures of organization, structures of governance, structures of academia, from silos to systems, to reveal the true nature of the world, to organize the world's knowledge accordingly, and then hopefully to power decision making and a better architecture for the world based on that knowledge. The precedent for this, acknowledging that putting the effort you're working on the same slide with the giants that I've put here, is unearned at this point, but it's a useful contrast for at least what the ambition is. When we look at the precedents for, and I think what this perhaps invites is the recognition that systems of knowledge are human-made, right? We didn't inherit the discipline as a structure of nature. It is not sort of imbued in the DNA of ourselves or the planet that the world needs to look this way or that we need to organize its knowledge this way. Google said that the better way of organizing the world's knowledge is by ranking that information based on things like popularity and relevance, but ultimately with a semantic backbone, where the atomic unit is all the documents, the media, the images in the world, and where the core relationship between things, between obesity and overweight and weight loss, so that we can assemble relevant information to a search, is semantic. And Wikipedia said, well, what if we leverage the big idea here of collective intelligence to assemble the world's knowledge, again, where the atomic unit is the topic, is obesity, and where the relationships, again, remain semantic. And so you can navigate your way through Wikipedia through semantic, historical, ontological, taxonomical type relationships. Incredibly useful when you're trying to grok something at its most kind of core level, but limited in being able to assemble systems. At System, the effort for us is instead, how do we discover how everything in the world is related? And the atomic unit, as I'll talk about in a moment, and as you'll see expressed through the efforts to map and visualize all this knowledge, is a measurable element. It's a variable. So we start from the premise of what if we could assemble everything that is measured in the world? Every biomedical variable, every biomarker, every climate variable, every socioeconomic variable. What if all of those could exist in one large-scale graph? And what if instead of relating them based on taxonomies and ontologies and semantics, we could instead effectively meta-analyze all the evidence that is being generated every single day by researchers, by machines around the world, and we could assemble all of that raw evidence with all of its statistical metadata and ensuring full provenance for where and how it was measured. And we could learn through meta-analysis effectively the nature of the relationships up, down, and sideways between this variable and everything else that it touches and is touched by. So to illustrate this a little bit more concretely, let's think about the way today that we might characterize a search for something like malaria, and then the way that we would assemble knowledge around it if we were working on a global public health problem, or if we were a team of epidemiologists or infectious disease specialists trying to assemble a research plan to tackle some aspect of malaria. Today, a search for malaria is simply limited by the data that will sit, the elements, the objects that will sit under the label of malaria and variants of it. So the malaria incidence per 1,000 population, right? The percentage of households with at least one LLIN, et cetera, the malaria proportional mortality rate. So things that are either directly semantically linked or things that sit within the very close neighborhood of that topic. But instead, if we were to assemble, as we did under a grant from the Gates Foundation very early on in Systems journey, if we were to assemble leading experts in malaria and we asked them to describe malaria, we did very quickly bump into topics of maternal health and nutrition and so many others, because to understand malaria is to understand the system, is to contextualize the emergence of malaria within its full biological, social, environmental, geopolitical context. And so what if instead we were able to regularly and reliably hold this whole context in mind, and we were encoding this element, so this set of relationships between malaria and everything upstream from it and everything downstream from it as the new atomic unit for how we modeled and made decisions in the world. So what if every time we accessed malaria, we had the ability to access instead this subgraph? And that means that we could assemble all the relevant and associated data, all the relevant and associated literature, documents, et cetera, experts, based on this system's view of malaria at an infrastructure level, powering every search, every LLM, every decision that we made. And of course, we can't think about this within sort of closed silos and then calcify and go deeper into the siloed structure of the world. It's critical, so we can't build a health system, right? We can't build a climate system, and we can't build a geopolitical system because it's one system. And so as the core first principle, the first principle underpinning systems architecture is one system. And that presents any number of architectural challenges, computational challenges, ontological, taxonomical challenges. How do these things speak to one another, literally? And then, of course, how do we model all of this in a way where we can connect, very importantly, something like a social determinant or a shift in climate and its effect on public health, that a particularly important nexus, reliably. And so to do this, we have invented something called the system graph. It is a systems model of the world that is only possible today because of a great many advances by a great number of communities and scholars and scientists and technologists in fields like AI, in graphs, in complexity science and network science, in causality and causal inference. And it's by assembling all of that set of philosophies, schools of thought, technology, science, that system is possible today. And so system is the first model of the world as one interconnected system. And we've started from health and then branching out from that. So the way this works is I mentioned earlier the variable. So the variable is the node of the system graph. The edge is sort of more complex. So the edge is effectively an automated meta-analysis of all the relevant evidence sitting in documents, in databases, and other sources that we can compile through our models that we build and pipelines that we run every single day to extract something like this from a document like this. So from this paper in the New England Journal of Medicine, systems AIs will extract these two variables, one having to do with HPV and the other having to do with invasive cervical cancer. It will identify the statistical model, the statistical relationship, in this case, an odds ratio of 16.4 with a p-value of, et cetera, in a particular population. So preserving context, sample size, so 118 women in Sweden, et cetera. And then full knowledge provenance for that atom. So in this case, the DOI of this New England Journal of Medicine paper. But that could be a real world data set, et cetera, et cetera. And so as we then assemble the relationship between HPV and invasive cervical cancer, so you could think there might be hundreds or maybe thousands of atoms that we are combining and recomputing every single night to better understand that relationship, better understand what's upstream from it, and recompute the subgraph around HPV and cervical cancer. This is the atom, though. This is what we're trying to assemble as a statistical understanding, allowing us to compute where possible things like the strength, the median effect, the sign, the direction, the extent to which there's agreement among sources of evidence, the extent to which there might be a gap in the evidence. All of these very important questions, meta-analysis questions, scientometric questions, all become possible with this rich data that we're assembling every day. This is an early effort on our part to actually watch the graph change. So that was a section of the graph. And in blue, pulsing, you're seeing edges where there has been a change. We've added new knowledge over the course of the last 30 days. So it's fascinating to see the graph evolve. It's fascinating to see specific edges change. And ultimately to see what we hope is sort of the true structure of nature being revealed. Now, really significantly, we are structured as a public benefit corporation, and core to our charter as a PBC is a commitment to make the essence of the system graph, so this platform that we've built, openly available, contributing it into the commons. And it's our vision that this become public knowledge infrastructure that drives new systems-based research and policy and art and design and philosophy and poetry and a world of contributions driving a more systemic understanding of the world. Beginning next year, and we'll be making some really exciting announcements next week. So stay tuned for that. We will be releasing our first snapshot of the system graph into the commons under a CC BY NC license. If you want to get your hands on that as soon as possible, please do reach out, and we'd love to chat with you about that. So these are some of the questions that we've been exploring ahead of releasing the first snapshot of the system graph into the commons. So one of them is, how can we understand a disease in terms of all of the factors that may contribute to that condition? So meaning, if we weren't discriminating between genetic factors, biological factors, social determinants, environmental determinants, the whole panoply of considerations of factors that give rise to disease, if all of it was available to a clinician, all of it was available to a public health official, to a researcher, what would that allow us to do? And so in this particular case, we were looking to model all factors that are within a couple of hops upstream of stroke, and then to classify them based on whether they were modifiable or not, whether they were social and environmental determinants or biological factors, and then to look at which ones could potentially be targets for public health policy to mitigate. So looking at the sign of the edges, to mitigate the prevalence of a handful of cardiovascular diseases in 5 cities around the world. And we published some of this work. It's up on our blog. And so really important to be able to now assemble a systems level view of every disease and to figure out how to give form to that. And one of the things you'll see in the next few slides is that the system graph is huge, and there's a tremendous amount of metadata available on the edges. And the visual language that we have today, as so many here know, is very, very limiting for being able to really arrive at sort of rich, meaningful characterizations of these systems. And I'll end with a sort of thought on where this might go. And I think one of the things that, this approach to design, this approach to visualization has been useful for is, of course, things like understanding the shape of networks, looking at roles within the network of certain hubs, of certain nodes, etc. But in order to either power some cognitive shift or to actually support a decision, they're quite challenging. And so I think one of the sort of big limiting factors right now for advancing true sort of systems understanding of these complex issues will be devising a new visual language for complexity, for interconnectedness. One of the other ways we can look at this, another area of research we've worked on with some partners, is if we were to see an uptick in a particular node in the graph, how could we use the system graph to anticipate what the possible and then probable next actions, next events, next happenings, next diagnoses, etc., might be, in order to build early warning kind of capabilities into, again, public health, climate, policy circles, because now we know. We were asked to sort of run this thought experiment of if that Alzheimer's node was COVID, and we could have, during the pandemic, kind of used the system graph to recognize what the knock-on effects might be of the things that we were starting to see COVID hit, whether biological, sociological, socioeconomic, educational, mental health. What might we anticipate next because of the known, sort of a priori known understanding of the structure of those downstream relationships? Could we have allocated resources differently to mitigate harm that was sort of unnecessary in society? And then we think about what does it mean to assemble a whole systems model of disease. Researchers and clinicians at Mass General, Harvard Medical School were asked a few months ago, what are the top unmet needs right now in healthcare? And in their top 10 was the absence today of a systems level view of disease. Our ability to see a disease in terms of not just an organ specific, sort of specialty specific understanding, but again, if we could combine everything that we know that affects it and everything that we know could intervene or treat, and everything that we know could be affected by it, and we could hold that system in some fashion, of course, filtering evidence, filtering the nature of relationships, considering causality, all the different kinds of things you'd want to run on this data to bring more sophisticated decision support kind of capabilities. But it starts from the premise of what if we had a systems model, systems level view of every single disease that wasn't limited by the organ structures, the anatomical structures, the specialization structures that are so prevalent in healthcare today. We're also interested in the effect of major sociological issues or sociological variables, so somebody's socioeconomic status, and how does that affect any number of mental health, of public health, of environmental, of all intimate partner violence, all sorts of different areas of society that today are highly discretized by function, by ministry, by department, if you're thinking about it from a government standpoint, by department from a university standpoint. So again, if we were to equip us all with this living, breathing whole systems model of an important sociological factor, and let's say swap this for loneliness, should we intervene on something like that and devise policy because we start to see what downstream effects it might contribute to? This can be incredibly powerful, we've seen, for starting to frame policy. We're also really interested in the links between sort of big neighborhoods of the system graph. And again, as I mentioned before, because of that first principle that it's one system, we can start to look at the collision between areas like climate and public health. So in this case, this was a study conducted to sort of to start to examine both at a snapshot at a moment in time today, based on all the evidence in the system graph, but then also if we were to run this over decades of evidence, everything is timestamped within the graph, what the relationships are between blue public health nodes and green, in this case, environmental factors like extreme weather events, carbon monoxide, particulates in the air, et cetera. And we could start to examine the effects and the changing of those effects 1 degree, 2 degrees, so direct and indirect effects on public health, because this is such an important topic right now. We can also, as I just started to suggest, we can also start to think about a longitudinal capability here. So so it could be really interesting for analysis of change in a system to plot and to start thinking about how has the composition, the weights, the nature of a system changed over time. In this case, this was actually the COVID system. So plotting it from the onset of the pandemic, March 2020, and running it through December 2023. And we were looking at, if we were to sort of run this, we were looking at what we were starting to learn as first degree causes and effects, and then also what we could have known as the upstream factors, 1 degree upstream of those causes or 1 degree downstream of those effects. So things that we could have either looked to prevent or things that we could have allocated resources differently to mitigate some unintended harm. Then one of the areas that we're really interested in now is everything we've talked about thus far has been kind of in the aggregate. So the node is for the world, right? Or it's the state of the evidence for air pollution, right? Or it's the state of the evidence for food prices, or the state of the evidence for COVID prevalence. But in order to build kind of infrastructure on top of on top of the graph that can really affect decision making, we need for each node in the graph to be able to absorb, to take in specific data. So the actual measurement of that, and you'll remember the nodes are variables, so everything can carry actual data. And they're designed to be interoperable so that in this particular case, we're looking at how can we assemble a specific graph for a specific patient, because we all face this challenge of a world that isn't architected the way we feel when we don't feel ourselves, or where we're trying to attack some chronic condition or pursue pregnancy journey, things that, or a complex disease like cancer. We feel the anachronism of our healthcare system not lined up with the system that our body is and that we feel it is. And so what if instead of over on the left, which is the way that lab test results are organized, let alone visualized today, suggesting that each result, each biomarker, each data point in the world, in this case, in our sort of health record, is discrete. What if instead we held, again, the context around each one? And again, I don't necessarily offer this as a visual solution yet, but as an architectural solution. So if this was what was powering how we now saw our health, and then we're thinking about the root cause of things, how to prevent things, what might be affected by things, what might be the most effective treatment, you can imagine how taking a graph-based approach, taking a systems-based approach, personalized to N of one, to you as a patient, could be profound. You could also imagine that I could swap this for the UK, and I could start to imagine what would it mean to take in all sort of national health data and environmental data and socioeconomic data for a given system, and now assemble a whole systems view of a country. So we're working now to develop these clinical graphs, that we call them, on top of the system graph for each patient, powered by the system graph, but designed to be fully interoperable with clinical standards so that this can actually power clinical decision support. And that's our sort of vision as we're building the system graph, is within specific sectors, how can we be building enterprise-grade versions of the graph that can power and improve decision-making, taking a whole systems view. So I want to kind of leave things in a different place, and this is with sort of pulling on the thread that I suggested earlier, that I think right now one of the big challenges that we had to embark on over the last 7 years, since I sort of first started writing the original research around system, we had to figure out what is the architecture for this. Is it tractable? Is it scalable? Can we compute these things? How does it interact with AI? How do we leverage LLMs for it? How do we feed it into LLMs? Et cetera, et cetera. How do we find all the necessary data that's necessary? How do we find all the data that's necessary to populate the system graph, to assemble a systems model? How do we validate it? How do we ensure the integrity of it? How do we ensure that we can preserve knowledge provenance? Any number of complex tasks that we've had to work on. I think one of the most interesting ones going forward is, how do we leverage this architecture, this infrastructure, to feel differently about the topics that we are confronting, the data that we're confronting, to actually sort of elicit a systems mindset around this data, this new architecture that can be incredibly powerful, but we need to find the way to link it to cognitively how we would internalize, make sense of, leverage, and ultimately sort of feel, right? Like grok and internalize. And I think this is where we sort of have to shift gears and move away from sort of science and technology, and then ultimately even design interfacing with science and technology to devise new interfaces. I think we're nowhere near sort of the interfaces that we need, the design language, the visual language that we need to achieve that goal. And so I think this is actually one of those moments where we need to look to other faculties to help inspire what will then be sort of the design brief and the science brief and the technology brief. And so I look at, artists who have very much understood the same thing that indigenous cultures characterized with Gideon Wendemine. Kandinsky said, to harmonize the whole is the task of art. Oates said, the ideal art, the noblest of art, working with the complexities of life and refusing to simplify. And I think these insights, these intuitions, these capabilities of sort of sitting with complexity, sitting with the chaos and the interconnectedness, and somehow distilling it into something essential, is the profoundly important and challenging task before us. We've been starting to engage with the creative community to start exploring this, and as we start to release the snapshots of our system graph into the commons, we'll invite these forms of collaboration, and really excited to work with all sorts of different communities on how to best tell stories of systems. But one of the things we've been starting to work on is what would it mean to sort of feel a system come to life, and not be limited by sort of the edge, but actually start to feel the dynamics of that system. I think one of the kind of really unfortunate limiting factors, just to kind of geek out on the design for a second, one of the sort of unfortunate limiting factors of the way we today kind of look at networks is that the edge is a flattening of a relationship. It was useful when the relationship can only be characterized in more simplistic terms, right? So is friends with, or something equivalent, but something that is really quite flattenable. If what we're really trying to say is that, oh, there's this profoundly complex relationship between A and B, and never mind A, B, C, D, and E, and it's changing in time and space in different populations and different moments, how do we honestly reflect that, and express it in a way that also evokes a feeling that drives action and that drives a different appreciation for the topic itself? And I'll sort of leave with this historical context that I find sort of endlessly inspiring, because I think sometimes it's really helpful when we are faced with something that seems utterly intractable, and beyond ambitious, is to look at grand projects that society has undertaken that are similar in composition, and were successful. In the 1960s, faced with the observation that the world was acting as if its resources were infinite, where there was no sense for conservation, let alone sustainability or environmentalism, Stuart Brand and McLuhan and Bucky Fuller had the idea that what if the reason for that is because up until that moment, we had yet to see the Earth as a sphere. We had yet to sort of like have this new mental model, and visual understanding, visual appreciation for the spherical and therefore limited nature, bound nature of the planet. and its resources. And they came up with this pin saying, why haven't we seen a photograph of the whole Earth yet? And they distributed them on college campuses in California, and then it spread around the country. And against the backdrop of Silent Spring, these two catalysts led to Earthrise 2 years later. And so now, for the first time, we saw this image. We were able to produce this moment, right? Society generated this image. And again, with Silent Spring, a great number of scholars have looked at the causal relationships between those two contributions and the birth of, in the next 2 years, the environmental movement. We had a completely different conceptualization of conservation, of environmentalism, of sustainability. It led to the Clean Air Act. It led to the first Earth Days. It led to the birth of the Environmental Protection Agency. It led to modern environmentalism. And so I think the opportunity before us is similar but different. Several years ago, very inspired by Brand's pin and the work of this whole community, I offered this prompt at a conference of complex systems researchers. Why haven't we seen it all connected yet? And I think that is the sort of prompt of our time, of an age of systems, where there is a great urgency for us to assemble a systems view of the world, but also for us to feel it, but also for us to somehow connect with it, not just in a technocratic way, but in a way that resonates, moves us, causes us to change, to act, to march, to vote, to take better care of ourselves, to think about prevention, to think about the planet. So we can take this to some asymptote through science and technology. But I think it's an incredibly exciting moment right now as we're starting to make some, we think, kind of hopefully meaningful contributions on the technology side, on the scientific side, to really start thinking about how we make people feel it. So I will leave it there. Very much invite follow-up conversations, partnerships, interest in getting access to the system graph when we release it next year. Please do reach out. But it's been a pleasure to be here. Happy to take questions.
Adam, thanks so much. I think very great data. It takes a lot of effort to harmonize, clean, interlink data in this way, and making it available to us so that we can derive value-adding products. Thank you for doing that. I was wondering, can you in your graph also represent the different spatial scales and the different temporal scales that happen in our bodies? Or you go from the meter-size human body down to the micrometer, nanometer scale. So that's 10 raised to the power of 10 zooms. Same for temporal scales. So you have electric signals be very fast, and then you have lifetime. So probably the same number of scales. How do you represent that in the graph?
Yeah. So from the resolution standpoint, it was really important to us to recognize that, so health is a good example here. We need to be able to account for mechanisms of action at the molecular scale, as well as relationships that can be characterized in more epidemiological terms at population scale. And sort of quite critical that all those things can live together. And so we've devised the architecture in such a way that it does span from the molecular to the epidemiological and everything in between. And that means that we have to have a variety of methods for inferring or computing the edge between those nodes in the graph, whether those are statistically modeled or whether those are understood through other experimental methodologies. All of those exist within the system graph today. in terms of temporal, so absolutely. I mean, I would characterize it in two ways. I mean, so the lag for effect, and then the graph itself being versions that we can monitor things over time and changes in systems. So one of the things we're working on now, just to introduce the first topic, is we're integrating real world data. So a term of art within the healthcare world. So de-identified patient data, so fully anonymized, de-identified, aggregate population level efforts like All of Us in the United States and others in the UK and elsewhere around the world. And in that case, because we are computing statistics on that raw data, right, as opposed to building models to extract a previously computed statistic by researchers using a methodology published in a paper. There we are looking at the appropriate observation windows for being able to detect the effect of some risk factor, some intervention, some treatment, some diagnosis on some other event that happens. And so when we are computing a lag in a relationship, it's very much something that we're now incorporating into the metadata in the graph itself.
Glad to hear that. We realized that in the whole person project, the Physium project that NIH has recently started to fund, that we actually need a lot more data that's continuous, like continuous glucose monitors, calcium monitors, etc. And then we need interventional data. So you need to ask a healthy human person to lay down, to get up, or to do some sport, or to drink a lot or a little, what you just did, without prompting me. That makes a huge difference what your body has to do. So having these external shocks, which are all in the normal range, and then seeing how the system can respond to it, and if it can respond to it. And I think this response gets less and less flexible as we age. And then also understand in how far random response is also not a good idea, and very static rhythmic heartbeats are also not a good idea. So I think we need to understand much more the interventional response of agental materials, right? So the entire set of cells we are made out of, proteins, teams of cells, the functional tissue units within our organs, all of those have their own agency. And there's really great research now on how to create interfaces to these agents so that you can talk with them and basically hopefully convince them to do the right thing as opposed to become a tumor or as opposed to become something that you didn't want to happen. And so there's a recent interview with Michael Levin, who was on the 24-hour event last year and hopefully comes back next year when we talk about the human physiome and how to model and map it. He very much has good arguments to make of how to kind of have a conceptual understanding of these agential material, to understand what they can do, how much they can remember, how much they can predict, how much spatial space they can care for. And I think these kind of concepts you might like to bring into system as well. And it's hard to get there because the current data that's captured, the once in a year lab results you get might not get you there. So I think we need new ways to capture the interventional reaction of our building blocks.
Yeah, very much agree. Yeah, I think one of the things we hope is that having this infrastructure in place creates the sort of receiving and sort of the capability for integrating this in a way that becomes immediately valuable. Hopefully being able to see the value of being able to integrate more continuous monitoring into a whole systems view motivates data collection. We're seeing that now with discussions we're having with healthcare providers around things like social determinants, where knowing that something is more or less important when you can only have so many minutes with a patient might motivate, right? We're going to run some tests on that over the next year, might motivate additional capture of important social determinant data, because you start to see its importance in understanding that particular system or a set of systems that might be important to that patient. So I think there's an interesting question now of how something like this can prompt and prioritize data capture, new data collection.
Yeah, I think we will absolutely need this. And then on the visualization validation side, I think there are some fascinating lines of research on maps of death and maps of health. So on our side, we have used data from the coroner's office from opioid overdose death to just understand how often somebody was resurrected from having an overdose, what other interventions they went through, how often they interacted with police and other agency and institutions. And ultimately, given the construction of the data set, every single one died ultimately. But it was super interesting to see these trajectories and what helped for how long, when was the relapse to the old state. And similarly, hopefully, we can also map health, because I think most of us are interested in not even becoming healthy, not even becoming a disease. So I think having existing data sets and existing visualizations that have had a huge impact in impacting how people make decisions, also in government, and trying to recreate them using the systems graph and using them also to get others to contribute data, which is always an effort that needs both sides, right? The receiving end and the providing end, and good arguments and showcase examples of what can be done if people collaborate would be super valuable. So we have quite a few on the attendees list. Please do feel free to use the Q&A section if you have questions. I think it's really super unique to have so many different researchers and experts from academia, industry, and also the arts and humanities world. And I think we all have to combine our superpowers, forces to think in systems. And Adam, I very much appreciated your highlighting of emotions, because oftentimes it's not good enough if we just help people understand something. They should eat healthier, they should do more sport, not good enough. You really have to get to their emotions. Oftentimes you have to fall sick in order to change your behavior and to change your habits and maybe also social environments. It's hard. Change is always hard. So I think it's super important to get to emotions. Typically, as researchers, we are not supposed to go there. We are supposed to just stay with the facts. That's also why we created the exhibit, because the exhibit lets us collaborate with science museums, with artists that absolutely know better how to get to the emotional parts. And in fact, tomorrow in the 11 a.m. session, tomorrow morning, last one, but not least, we will absolutely talk about emotions, how it triggers transformation, but also how it can sustain action. And I think it's not a matter of just doing one good step. You have to do this the rest of your life, right? If you talk about life changes, eating healthy, doing sport, and lifelong is a long time. And so it's really important for us to understand how we get not just to rational decision making, but also to the emotions that then trigger action and sustain that action.
Absolutely. Yep. We're really interested in, what does it mean for us as individuals to, hold this information front and center as we navigate life. We are starting right over the last decade to have more data at our disposal as individuals around different parts of our life, right? Whether it's financial, health, energy, etc. That's been the last sort of revolution. I think where we go next is how do we see this all linked together in order to drive the best possible preventative actions or decisions in all sort of walks of life. But that really does mean how to present that information transparently, understandably, but also in a way that drives action.
Yeah, absolutely. You mentioned that data will become available, and many of us work for free if there's high quality data, because data wrangling by itself is oftentimes 80% of the budget. It's just what it is. If you want to have meaningful data visualizations, you have to have highest quality data. And just getting access to this data is very valuable to many here on the call. Can you tell a little bit more about the conditions under which you might be able to access certain parts of the knowledge graph or all of it? I teach an information visualization course every spring, 130 students. They work on real-world client projects. I would love to have that as a client project. I think they would do something really cool with it. It's basically them, right? They might be part of that graph, at least as part of one demographic group in there. And again, all you have to have is a data set, a question, and 2 hours of time, because we need to be able to go back and forth about the data and to get a thumbs up and thumbs down at the end. And so I think this would be an amazing project to work on for these teams. And they can do temporal, topical, geospatial network analysis. And I think they would apply large language models to generate all kinds of visualizations. And you can very quickly, as a human being, see if that's a good visualization or not. And then, of course, you have to validate if it actually represents the right data. But I think there's this large language model, it's very, very easy now for non-programmers to have a conversation and get to a visualization that definitely shows you trends, outliers, and other parts, the patterns that might be relevant for decision making.
Yeah, so we'll be making an exciting announcement on early next week that will sort of speak to the sort of infrastructure we're putting in place, funding we're putting in place to make all this public and really secure the sort of public benefit underpinning of system. So stay tuned for that early next week. But yeah, the next sort of major milestone for us will be a full snapshot kind of release. So moment in time, here's the whole system graph. All this data that we're talking about, very much designed for research, very much designed to drive the kinds of projects and hopefully invite the kinds of contributions that you mentioned and all the papers and projects that we hope will come from it. So right now we're gearing up on our side to be able to sort of exactly as you just said, so be able to support researchers and have sort of good community functions around this and events and conferences so that we can support a community and invite contributions and feedback from that community as we improve the system graph. So all that is coming early next year.
Super. Yeah, we will be watching out for that. Thank you so much.
Yeah, my pleasure.
Great pleasure. Yeah, hope we talk more.